Tony Malott spent 40 years managing mission-critical platforms and regulated operational technology. Over time, a severe bottleneck emerged in his workflow: his own brain. He was acting as the database, the scheduler, and the relationship graph for every active project, leading to inevitable cognitive overload. Generative AI offered a massive leap in implementation capacity, but it had a fatal flaw. Useful intelligence existed only inside a chat window, and the moment that session closed, the intelligence vanished. The AI ghost disappeared. Tony's first instinct was to try and trap the ghost. He built projects like Immortal and Oracle, designing elaborate memory packages and context sinks in an attempt to keep a single AI session permanently alive. This approach created incredibly fragile systems. It required constant prompt babysitting to keep the model on track. What looked like a breakthrough in artificial memory was often just the system confidently hallucinating its past. Relying on a continuous AI session is essentially institutional amnesia masquerading as an oracle. Under that model, the human operator is still stuck acting as a stressed, overcapacity database, desperately trying to keep the machine awake. The solution required an architectural inversion. The objective was no longer to make the intelligence immortal. The objective was to build a system that easily survives without it. Tony called this structural decomposition, GhostMesh. In this framework, the intelligence becomes a temporary worker, and the surrounding structure, the mesh, becomes permanent. This diagram shows how Git discipline externalizes that continuity. GitHub issues define the durable intent, while branches act as a strictly bounded workspace. Temporary AI workers attach to the timeline, perform their task, and disappear. Pull requests act as proposed changes. The AI does the heavy lifting, but it cannot authorize its own deployment. A human operator must approve the change. By moving memory at authority out of the chat window and into version control, the temporary AI worker can safely vanish. The underlying understanding remains perfectly intact within the system. This chart shows human output against machine-assisted throughput over a compressed 4-day timeline in July 2026. Exactly 51 pull requests were merged across the platform in that short window. This volume proved that a single accountable operator could govern a complex multi-repository ecosystem by leveraging AI implementation capacity. However, this exposed a severe operational bottleneck: manual ignition. Tony still had to manually copy prompts, paste context, and act as the human transport layer, moving data between disconnected surfaces. Raw AI throughput does not equal autonomy. If the human operator must still manually carry the work between tools, the machine works, but the human is still trapped in the loop. To remove the human transport layer, GhostMesh executed what Tony called the first crossing. The system ran an event-driven task across a real external repository boundary, automatically revoked its credentials, and cleaned up its workspace. Next came the second crossing. This was a high-trust proof within the skills repository, successfully handling a materially different security domain by using distinct, independent observer credentials. This decision tree shows routing logic for execution economics. The system prioritizes deterministic adapters for mechanical work, refusing to default to AI unless the task requires actual reasoning. It intentionally stops at external gates, explicitly refusing an expensive AI model if a cheaper route works. This proves the architecture is optimizing for the minimum trusted privilege compressed, rather than maximizing model token usage to look sophisticated. Mature AI architecture uses intelligence exclusively for the smallest novel delta. Once that specific reasoning is complete, the system immediately returns to standard deterministic infrastructure to execute the result. Despite these architectural successes, mundane operational failures persisted. One major defect was silent pickup, where a task appeared active to the user in a chat interface, but actually possessed no durable execution state in the background. Another was the false owner ready handoff. All the mechanical backend checks would flash green, but when the user clicked the actual UI route to review the work, the page was broken. These operability gaps forced a strict redefinition of task completion. The handoff itself must now explicitly prove that the human owner can successfully load and review the intended product. The system was highly safe. It successfully prevented unauthorized deployments and protected the production environment, but it was incredibly rigid and high friction to operate. Preventing silent corruption is the mandatory first phase of any serious control system. You have to firmly bound the damage before you can start reducing owner friction. On August 6th, reality struck. A major GitHub Actions and Pages outage completely paralyzed the GhostMesh execution plane. Yet GhostMesh's bounded recovery held firm during the crash. Unfinished mutations were rolled back, and failures were preserved as durable evidence rather than disappearing into a silent void. This incident highlighted a critical provider concentration risk. While Tony's system semantics were strictly provider neutral, they remained entirely dependent on GitHub's orchestration to function. This triggered an architectural mandate for sovereign local execution. Tony pivoted to turn his local workstation into an independent provider-neutral execution node, severing the absolute reliance on a single cloud vendor. This diagram shows the Tony brain memory plane undergoing a similar shift. Instead of full archive ingestion, the system moved to measured retrieval engineering on a strictly bounded 50 conversation chunk. GhostMesh evolved from an AI architecture demonstration into a governed operating system. It proved its central thesis: the ghost can disappear, the continuity must not.